Hi everybody. Today we're starting objective 2.2a. It is got 3 parts to it. We'll go to 2.2c. Today's title is the standard form of a quadratic function. I couldn't fit functions on there, so I just called it quadratics. Your objective, you will be successful when you can convert the general form of a quadratic function into standard, also known as vertex form. It's a lot more friendly for graphing. So we're going to talk about that. It does take some practice. You do have to be patient, but it does have its uses. So let's start off with what the general form of a quadratic function is. General form is this: f of x is equal to ax squared plus bx plus c, which is familiar, I'm sure, to all of you. Standard form looks like this: f of x is equal to a times the quantity of x minus h squared plus k, where your vertex is at, I like to write the opposite of h, k. Some people just write hk, which isn't incorrect. But remember, you're inside the parentheses, and that's a horizontal action, and you always do the opposite. Because your h is a horizontal shift, and your k is a vertical shift, and your a is a vertical stretch or a vertical flip or a vertical compression, or maybe two of those three things. So what we're doing is we're putting it in the form so that we can just take the parent function and graph it, and then transform it and regraph it without making a table of values. So we're going to do this, and I have 5 steps, and I have coordinated with Miss Ratcliffe, who's teaching the AP Calc, because I wanted to make sure that I taught it the same way that she does. And if you've had her before, I'm going to teach it the way she already did when you were in her additional math class. So here we go, step 1. I will color code after I'm done writing the steps down. I'll go back and color code what each step in a different color. I'll put a little dot next to each step. Here we go. Step 1. We are going to move C to the other side. So we can get the C out of the way, just like we did when we were doing our circles. Then we're going to factor A, just A, out of ax squared plus bx. Then we are going to complete the square. Now, there's more to it than this. We're going to complete the square. Remember, when we complete the square, we add the square to both sides. However, there is a caveat to this. I'm going to write this. Be careful. If you're going to make a mistake, it's going to happen right here. Be careful. You need to remember to multiply A times the square before you add it to your C term that was moved to the other side. And I'm going to grab my red pen. It's really crucial, and that might not make sense, but when I put it into action, when I do a problem here in a second, you'll see what I'm talking about. Really important that you remember that. Okay, now I'm going to go back to step 4. You're going to factor the left and simplify the right. And then step 5, going to isolate your f of x and identify the vertex, which was the point to begin with. We're going to take this equation, it's not very friendly, and put it into a graph-friendly version or form. Okay, so let's color code. So I'm going to do step 1 in green, and I'll do step 2 in purple. Obviously, I'm going to do step 3 in red, and I'll do step 4 in blue. So those are the colors that I'm choosing, and I'll write everything out in my black pen, and then I'll go back and underline the changes in the proper colors. Okay, doke? So, as I said, when you're given a quadratic equation in this format, in general form, well, if I wanted to find the zeros and use a quadratic formula or a factor to find my zeros or my x-intercepts, it's really friendly for that. But you know what? So is vertex form. And vertex form gives us more information. So we're going to convert. Now, the one thing that I like to do is I like to move my f of x to the other side of the equation so that I can do the same process that I did when I was doing my circle, when I was completing the square to do my circle equations. So I'm going to rewrite it, and not in purple or blue, like so. X squared plus 3x plus 5 equals f of x. And of course, if you want to be lazy, you could just go, equals f of x and go like that, if you wanted. Actually, that's not that lazy, is it? It's kind of smart. Okay, so step 1 is to move our c term, our y-intercept, to the other side, right? So I'm going to take that over there. So x squared plus 3x. I'm going to leave its spot open so I can complete the square, minus 5. That's our first step. I'm going to underline step 1. So that process right there. Subtract it off to the other side. Step 2. I'm going to factor the a out. That's what it says. And I know that the a is 1. Just hang with me for this problem because I want to do every single problem the same way. So our a is 1, right? Right? So we're going to factor out a 1, which doesn't really change anything. And I'm still leaving open my spot for completing the square. So we're factoring out the 1. And then I'm going to take out my purple pen and I'm just underlining that. That was my factoring step. Factor out the a. When your a is 1, you can skip that step pretty much when you're doing your homework. Now we're going to complete the square. So back to my pencil. So cut your b term in half. I'll write it down here so we can see it. Cut it in half and square it. So that's 9/4, right? Because you're squaring 3 halves. Here, I'll do this. See it? Cut it in half and square it. 9/4. But before, remember now, if I add it to this side, I have to add it to that side. But I said be careful. You have to multiply. I'm going to grab my red pen here. Here it comes. I have to multiply 1 times 9/4. Because on the left side, I'm multiplying 1 times 9/4. So I have to also add 1 times 9/4. So both of them have to go over here. If you're going to make a mistake, that's the mistake you're going to make. And it's not a mistake if your a is 1, but it's a mistake if your a is a half or a -2 or anything else. Okay, so we completed the square. That's step 3. Step 4 is to factor. So let's factor out our perfect square trinomial here. What do I write? X plus Come on, guys. What? 3/2 quantity squared. That's right. Equals f of x minus, well, maybe it's not minus. Let's do some math here. We have to simplify this. So maybe real quick, I'm going to write -5 as -24 plus 9/4 so that I can actually combine those two things. You guys see why I chose -24, right? Because they need that same denominator. So I think that's -11/4, right? So what I did was I factored the left and I simplified the right. Okay, so last step is to isolate the f of x. So I want to reincorporate this number, this constant that I moved off to the other side. I need to reincorporate it because it's now my k term. I need to reincorporate it into the problem. So it's coming back this way, so we'll be adding 11/4 to isolate it. So we get f of x equals 1 times x plus 3/2 quantity squared plus 11/4. And the 1 is redundant in the situation, but I'm not going to change my notes. What's the vertex? Because that's the left step. Identify the vertex. So what is my parabola doing? Shifting off of 0, 0. My vertex is shifting off of 0, 0. Which direction? Left 3/2, and then up 11/4. You're just using your transformations. Does it have a stretch? Nope. No stretches, no shifts. No stretches, no reflections. It's done. It's much friendlier. Okay? All right. So let's go do this next one. This next one will go a bit faster. It's not as mean. Ready? So first, shall we be lazy and go like this? Yeah. Again, that's not lazy. That's efficient. Right? Okay. So we're going to subtract the 7 or add the 7, right? To the other side, and I'm supposed to do that in green. Okay, I'm going to back up because I want to go through the same process every time. So -2x squared plus 4x, leave a space, equals f of x plus 7, because I am moving this -7 to the other side. Okay, we're going to factor out the a, so we're going to factor out -2. So imagine that you're dividing a -2 out of -2. -2 divided by -2 is positive 1. Positive 4 divided by -2 is -2x, and that's a negative. I'm going to clean that up because we're factoring out, and we're going to leave that open. Equals f of x plus 7, and I'm going to grab out my purple pen, and I factored out the a. Really important to do that because that's your vertical stretch and your vertical reflection. All right, so now let's complete the square. So x squared, I've got to keep going with my process here. So we're cutting the b term in half. So -2 divided by 2 squared. Ready? So -2 times x minus 2x plus 1, right? Equals f of x plus 7 plus -2 times 1. Because remember, what we do to the left, and we have to multiply that -2 times 1 on the left, we have to do on the right. Okay. So let me underline my complete the square and my add to both sides. There we go. Now we factor. So what do we get? No, that's an x squared, people. Sorry about that. Thank you. Factor it. X squared minus 2x plus 1. Okay, if we're struggling, that's a problem. Okay, so I'm going to come over here and I'm going to factor it really quickly. You're looking for numbers that multiply to 1 and add to -2. That's -1 and -1. So x minus 1 quantity squared. Remember, when you factor it down, because you created the perfect scenario here, perfect square trinomial, you just take the square root of the x and you take half the b. Okay, equals f of x plus 5. Okay, so we factored the left, we simplified the right. And all we have left to do now is isolate the f of x. So we're going to incorporate the 5 by subtracting it back to the other side and isolate. So f of x equals a -2 times x minus 1 quantity squared minus 5 with a vertex at 1, -5. Opposite of h, k, right? Shift right 1, down 5. That's where the vertex is going to go. Okay, last one. Not feeling really friendly, this problem at all, right? Yay, fractions. Good attitude. Okay, rewriting it in a more comfortable version. Here we go. 1/2 x squared plus 3/2 x. We're going to move that 1 to the other side by subtracting it. Leave that space open to complete the square, minus 1. So that was our green arrow, actually. Moving that over. Step 2, factor out the a. So we're going to factor out a half. Wrong color. 1/2. So do 1/2 divided by 1/2. 1. Do 3/2 divided by 1/2. No, it's 3. Remember, it has to get bigger, right? If you need to see it real quick, just do 3/2 divided by 1/2. So keep change flip, 3/2 times 2/1. That's 3. Just go off to the side and do it real quick. It's not going to kill you to take a little time to do that. All right, and we're leaving that space open so that we can complete the square equals f of x minus 1. Grab my purple pen so that I can indicate that that is my factoring out my a term. Okay, now we're completing the square. So we're going to cut the b term in half and square it. So what am I putting in there? 9/4. X squared plus 3x plus 9/4 equals f of x minus 1 plus, what do I put here? 1/2 times 9/4. Because remember, what I do to the left, I'm doing 1/2 of 9/4 on the left, so I have to do 1/2 of 9/4 on the right. I'm going to underline my adding of my terms in red. Okay. Now we factor. I'm going to scroll up just a little bit so I have some more room here. Okay, so 1/2 of, let's factor, x plus, come on, quickly, cut the b term in half. There it is. All right, quantity squared. Good. Equals. We're going to have to do a little bit of manipulation over here, so if you don't mind, I'm just going to do my simplification here. So this is 9/8. Do you agree? 1/2 of 9/4 is 9/8. Right? So I'm going to convert -1 to -8/8 plus 9/8 so that I can add those together. And I believe that gives me 1/8. Positive 1/8. So that's my simplification and factoring. So factored the left, simplified the right, and that was my simplification process. And then lastly, we just reincorporate the 1/8 by subtracting it back to its original position. So we get f of x is equal to 1/2 of x plus 3/2 quantity squared minus 1/8. And then, of course, we identify the vertex because now we can see it. It is -3/2, -1/8. And there you go. So I am going to ask you to do exactly these things on the 8 problems that I've given you for homework. So you will have done it 11 times by the end of this assignment, which should give you ample practice to get comfortable. I'm also going to give you the vertex of all the problems. I'm not going to give you the equations, but I am going to give you the vertex of all the problems so that you know when you get to your last step, if you've made a mistake, you can go back and look at it. So you're doing 1 through 8.